Now we're going to talk about solving two-step equations. And what I mean by that is there's a couple of operations that we need to undo or unwrap to figure out a missing number, or what we call a variable. Now there's a couple of different approaches, so I'm going to start with the conceptual approach. And the conceptual approach means if you're somebody who's pretty good at mental math, but writing things down's never been your style, this might be a way for you to approach problems on this level that aren't really complicated, and there is a systematic approach. So we're going to talk about what does it mean to solve, and this is something you can follow mentally for the most part. Okay, to do the conceptual approach, the first thing you want to do is identify your variable. When I say variable, I just mean the unknown number. And once you find where that's at, you want to walk yourself through, almost verbally, and say, what is happening to this variable? What goes on here, and what comes first? And here's what I mean by that. When I look at this x right here, I'm just going to list out what is happening to this x. The first thing that happens to this x is it gets multiplied by 2. After it's multiplied by 2, then it looks like it is added to 5. And once that happens, the result is 11. Now all I did was list what happened to it. I haven't really figured anything out yet. But if I want to kind of go in reverse and back things up until I get to the beginning number, which is what I'm trying to find, what was that beginning number that makes this possible, then here's how I do it. I say, well, I ended up multiplying by 2, adding 5 to get 11. So let's start at 11 and move things in reverse. Instead of adding 5, I'm going to subtract 5. And if I subtract 5, I get to 6. And then I'm going to divide by 2 instead of multiply by 2, and I end up with 3. Now 3 is what we are saying the value of that variable is. Let's test it out. What I mean by that is let's write out what this equation would be if 3 was there instead of that x. And we just want to check to see if it's true. 2 times 3 is 6. 6 plus 5 equals 11. That is true. So our answer was x equals 3. Now, that's a conceptual way of approaching it. And when we only have a couple of steps within a problem, it's not that complicated to follow along, especially if this ends up being a nice whole number. As you can see, I already messed up and wrote a 1 there on accident. That's why it's always a good job to check your work when you're done. Now, as we move on, it will not always be easy to follow this mentally. You get 3 or 4 steps within a problem, it's pretty tough to keep track of what you're doing. I'm not saying it's impossible, but it's a lot tougher. So we've developed what's called an algebraic approach. And this is just a systematic way of always approaching it so you don't have to mentally keep track of every number and every operation within the process, especially when things get more complicated. Now, the algebraic approach is based on order of operations. And order of operations is something you've seen for many years. Okay? Now, this is kind of an acronym, PEMDAS, that sort of reminds you what comes first. But when we're calculating something, parentheses or grouping symbols are always what we hit first. We always try and take care of those. And then we evaluate the exponents, if there are any. And then multiplication and division, even though multiplication is written before division in the acronym, it doesn't really matter. We move left to right. If the only thing left in a problem is multiplication or division, we go left to right. Okay. One of them is not necessarily supposed to come before the other. Same with addition and subtraction. If that's all that remains in a problem, we go left to right. So left to right. Now, why am I bringing this up with equations? The reason I'm talking about this is when we want to undo or solve an equation, figure out that unknown number, we are going to basically go backwards, which means we are going to do the order of operations in reverse. Now, when I look at this problem up here, I say to myself, what normally comes last in order of operation? Oh, that's addition and subtraction. So that's the first thing I look for in my problem. And what I see here is addition and subtraction. So I'm going to do the opposite, which would be to subtract 5. But remember, I have to do it from both sides of the equation. It's the same thing we did up here in the red. Look right up here, it's the same thing. We're just writing it in a more systematic, easier to read version. So 5 plus negative 5 gives me 0. So 2x is kind of by itself now. There's just a 0 there, which I'm not going to write. On the other side, 11 minus 5 is 6. And now this looks like a one-step equation that we worked on in the previous video. 2 times x, so I'm going to do the opposite, which is divide. And by the way, that's the same thing I did way up here. It's just written in a more systematic approach. But I'm going to divide the other side by 2 also. Whatever I do to one side, I have to do to the other, so I don't change the meaning of what's there. Those become 1, so I get 1x equals 3. Notice it's the same answer that we had through the conceptual method, and I'm fine with people doing it this way. If you can keep track of things mentally, by all means, do that. Mental math is great. But there will come a time where there are too many operations to adequately keep track of what's going on, and so that's why we're learning this systematic approach right here. I hope that helps you a little bit in your approaches to solving algebraic equations. Just remember, even though something may not look exactly like this, there are ways to manipulate it to make it fit what we're trying to do without changing what it means. And that's what we'll learn in future lessons, how to make things look this way, even if they don't appear to at first.